We tend to think of clouds as large systems that are just always on and available. But what happens when a large-scale cloud does need to be rebooted? Our next speaker has firsthand experience with this, and the secret recipe in doing just that on a cloud at scale. He has been known at his time when he was at Amazon as the master of disaster, but his current role is as co-founder of a company called Opscode. Please join me in welcoming Jesse Robbins.
All right. So hi, I'm Jesse Robbins. I'm the co-founder of Opscode, chief community officer there. And we make Chef, which we hope most of you use, certainly many of you use, and we are the leader in cloud infrastructure automation. I wanted to begin, seeing as it's Valentine's Day, by asking a question. Who wants to press this button? Anyone? Okay, you will receive candy if you press this button. Someone want to press the button? Anyone? You got to press the button. Aha, we have a taker. Candy for you. So there is always someone that presses this button. And there is probably about half of this room that is experiencing fear and panic. This is an EPO button. This exists in most physical data center facilities. Its equivalent will certainly exist in the cloud data center. This is rebooting a cloud, which is something that will happen to many of you. So before I talk about that in depth, I took a detour to become a firefighter. So I actually did my firefighter internship here in Palo Alto, or nearby in Palo Alto, and I used to run around Mission College nearby. I have thrown up while running many times around this facility. So there's that to look forward to. I took that to Amazon, and I became what was called the master of disaster there, which basically was turning the company operationally into something of a fire department. One of the things that every company has learned as they've reached any sort of legitimate scale, any big scale, is that complexity always increases. No matter how many times you try to simplify, it always increases. Latent defects, those are those little niggling things that get in there and take out your website, tend to accumulate and cause crazy failures to happen. As most of you know, when we move to the cloud, we depend a lot on these services, and we often think of ourselves as saying, well, but it'll be 4 nines or 5 nines or a billion nines or whatever. What's interesting is that most people fail to understand that availability is multiplicative. So 3 9 services equals 1 2 9 service. And that's why so frequently we experience failures of increasing complexity and terror, and that is why that big red button is so scary. The interesting thing is that every organization goes through basically the same thing. So there was a big AWS outage last year. There will be many other outages. There have been outages going back throughout the history of infrastructure as we know it. And everyone goes through the same thing. First thing is denial. This is not happening. You're tapping on the glass, like, oh, I'm sure that one gauge that says web orders just went to 0. Well, it can't be that bad. Then there's a lot of anger. Just how the heck could this be happening? Usually it spills out onto Twitter and blogs and all sorts of other things. This is followed by a lot more anger. I have to work really hard not to swear when reading these, just because I want to help out. But anyway, you've all been there. You've all seen it. You've seen the craziness that occurs when we have totally predictable failures. Then there's the inevitable bargaining. Sometimes people loop through. If we just do this one thing, if we just switch this one technology, things finally will stop failing. Then there's depression. Well, what's the point if let's not even move to the cloud. Screw it. If this is just going to happen anyway. And then finally, you get to acceptance, which is that you hear failure happens. We'll just have to design for it. And that's what you hear from every big company, every single one. Failure happens, design for failure, embrace failure, healthy attitudes about failure, become resilient to failure. Every organization must learn both at an individual level, as in the people that keep experiencing this over and over and over again, that this is going to occur, and then organizationally until this becomes part of the culture. So the interesting thing here is that there is a way to help people learn those lessons without having to experience disastrous failures. And this is something I created, although there are many different versions of this. Facebook has one, Google has one, Zynga has one, Netflix has one. They call it the Chaos Monkey or Chaos Gorilla. I have been called the Chaos Monkey or the Chaos Gorilla by others, which I'm not sure is a compliment. But it's a program, I called it Game Day, and basically it's where you break things. You reboot the cloud. You turn things off. Large-scale fault injection across critical systems. It's part of a discipline called resilience engineering, which I don't have time to talk about today. But what's important is this type of engineering is not new to the world. We are not creating new art. It is merely new to us. So most importantly, it's a function of people first and then technology. Doesn't matter if you use my technology, if you use someone else's technology. What matters is that the people understand that failure happens and you're going to have to deal with it by engineering for it, planning and preparing for it. So the benefits of Game Day, or a Game Day type exercise, are simple. The first is that you well, first of all, let me just ask this question. I'll ask it again in a little bit. But how many of you have experienced an impossible failure? Raise your hands. Really? That's not very many. Well, I think most of you are lying. So the reality is that we all find ourselves in these situations where we deploy software that, oh, if we had just known that one thing, but it could never possibly happen again. We depend on services that should never fail. And what we find is that by going through an exercise where we first prepare, we say, look, you know what? I'm going to power off your cloud data center. I'm going to shut down all those machines in that availability zone. You cause people to prepare, which improves your infrastructure approach. The second is that when you actually hit that big red button and earn your candy, like this gentleman did, you build confidence in your ability to respond to failure. And more importantly, you build that cultural ability to actually handle these situations without them becoming a disaster. The last thing is that those impossible failure situations. So if you search for outage postmortem on the internet, what you will find is, and we'll talk about this in some depth, a series of people talking about how crazy that perfect storm was. So the way you do this, the way you actually press that reboot button is by starting small. So you don't want to start on the very first day with the worst possible failure scenario. You want to make it easy. So this, like this kid here, they're not having to fight that giant hose back. They've got a firefighter helping them. That's your ops and dev people who understand this. Then you want to build up and increase awareness. You want to teach your people, you know what? We're building on these new technologies. We expect that they will fail from time to time. And we want you guys to start thinking and building for this new scenario. Over time, you see that your teams will build confidence. Again, this is the difference between a company succeeding at scale on the web and a company that is struggling, when they're able to handle outages, even little small ones, with the same excitement and enthusiasm as this little girl here, who is going to be one heck of a firefighter someday. Finally, you build up to the full-scale live fire exercise. When you actually press that button, you turn everything off, you see what breaks, you see how people respond. This is crucial to success. And the reason is that you cannot learn the lessons from failure without going through failure itself. And so as a result, if you want your people to be great when the fit hits the shan, as they say, you need to have taken them through it at least once first. That's why we do fire drills. That's why we teach you basic road safety techniques. Eventually, what you learn from these exercises is it turns into what we call safety standards and building codes. The engineered things that keep you safe in this room are a product of the experience of mechanical and building engineers who have learned through painful experience what works and what doesn't to keep people safe. We are going through exactly the same pattern on the web today. The other thing, and this is just a personal note, I hate being the shortest firefighter, so this is me. You can probably see which one I am here. I need a bigger hat, is I think my solution. Anyway. Failure-free operations require experience with failure. So that's why you see these big organizations who embrace the reboot button. You have to do that in order to work in this new world because things are going to fail. So I figured I would sort of jump ahead to the lessons learned from every postmortem that I have ever been a part of or read online. Or had someone talk to me about. How many people in this room have been through a postmortem process of some kind? Raise your hands. A lot of you. Okay. So I'm going to come back to this root cause thing. So it is always a perfect storm of impossible events. That's what caused it. With this one thing that we forgot about or we didn't know, or that one guy's desktop, that one guy's desktop has gotten me an awful lot, more than I would ever like to admit. But we could never have known that there was that one creeping dependency, that latent defect. And that's what got us. And what's interesting about that is that if that's what always gets you, then what you need is not to try to build that out of the system, but assume it's there to trigger those latent defects. The first lesson that everyone will come away with is that they have a bunch of manual processes which we need to automate. It's either one or two, typically, in their ordered list. So how many of you have no manual processes that you need to automate? Raise your hands. I'm hoping I don't see any of you with your hands up. What you have to do is automate all the things, okay? This is the response. Like, you're going to say, you have a bunch of manual things which you need to automate. Culturally, you actually have to get to a place where you say, you know what, I am going to automate all the things, and just embrace it and love it. We talk a lot when we talk about cloud, and there's been a fair amount of discussion over, even in the workshop days yesterday and this morning, you're hearing versions of this concept of infrastructure as code. Now, I founded and love a company that does automation, but at the core, there is this sort of desired end state, which is the ability to reconstruct your business from nothing but a source code repository, an application data backup, and the bare resources, be they bare metal, bare cloud. I don't know what bare cloud actually means yet, but we'll figure that out. I'm sure there's a standards body working on it now. And this is the desired end state. We will never get there. There's no way to finally be done because it is a continuous process. But this is what we're looking to. This means things like continuous integration, moving to continuous deployment. This means things like having automated load balancing systems that fail back and forth between complex environments. This is the future. When we talk about the future of the cloud and how it's revolutionizing everything, this is really what sets the base for that. You have to embrace this. My company makes Chef. Chef is very good at doing this. It is the language that people use. There are others, Puppet, CF Engine, probably projects that many of your companies have started internally that you're trying to build out. The point is, getting to this place is what is going to be your future. Alistair asked me specifically to talk about this. So there is a migration from this concept of golden images being the way that we did this. And golden images are awesome in a static environment, but they really kind of suck for the cloud environment. One, gold is really heavy and it's pretty expensive, and so I personally think it's probably a bad idea to build infrastructure out of it. It's hard to move around because it's heavy, and more importantly, it doesn't work with the patterns that we see today. So infrastructural complexity goes up in the cloud. And so when we want to add things which we expect to be able to do seamlessly, we can't just do that by cookie cuttering. And so when you add one new box to a stack, you have a minimum of 12 changes that you have to make just to bring that one machine in. That gets a lot worse when you move to a giant data center model with an entirely new availability zone, whether it's on a physical facility or cloud data center. It is combinatorial and an order of magnitude increase. So your clone army cannot beat automating all the things. Second lesson, we need better incident management. So we talk a lot about, many of you have heard the term DevOps. I've certainly spoken here at least 2 years, or at least the last 2 of these, about DevOps and these ideas. It doesn't matter if you think DevOps is good or bad. What you're really talking about is being able to work together better under periods of stress. And the cloud operating model makes you have to be able to do that. I learned to do this in the fire department. Now, most of you cannot take the 3 years out of your life to become a firefighter, although I actually recommend it. It's pretty rewarding. But what you can do is learn from the organizations that have gotten great at this. So large-scale, complex incident management is not a solved problem, but there is another group of people that have been working on it for a long time. There's a method I like, which is called incident command. It's not well adapted perfectly to IT, but ITIL isn't well adapted to the cloud. So when there is somewhere in this a new discipline to be created. But if you want a head start, this is where I would start. Working together in complex situations, when you've pressed the reboot button, your infrastructure's failing, nothing's coming back up, you don't know why, you don't have the common things that you use to coordinate, which describes most of the incidents that people have for the first few times, depends on this change in culture. Now, you might call it DevOps, you might call it just good web operations, you might call it how you do things. It doesn't matter. What matters is the expectation is that you're going to be working together in a new way. You're not just throwing stuff over the wall anymore. You're going to see deeper involvement from the business and the development organizations in ops and vice versa. And this is the pattern that successful organizations use. Amazon is public about the fact that they put their developers on call. Google has the site reliability engineering teams. Facebook has similar approaches. And so what you find is that this change is now mandatory for success at scale. It is, in fact, a natural byproduct of it. And so the forces seem to direct everybody in basically the same way. The last thing I'll say on this from the cultural change standpoint is that it's actually pretty fun. Working together better on complex problems under stress brings a kind of team camaraderie that you can't really get any other way, and that's why game days are so awesome, is when you finally powered a full facility off and sent a surprise power off and sent all the equipment in that facility back to the vendor, which I've done, which initially doesn't make you very popular. When people survive that and are able to pull through it and there's no impact to customers, they feel incredible. And that sets a pattern that will change the direction and success of your organization. And it's pretty fun. This is me setting a good example, by the way. I am both breathing fire and I'm wearing my safety gear in case something happens. So the third lesson is either your load balancing or your website or your DNS or your database or your deployment system or your storage system or your provisioning cloud, networking layer, et cetera. The failover thing that you built that you said, okay, well, that's how we're going to do DR. Well, it didn't work. But we thought it would work, and it was only because of this one time, this unique combination of events that it didn't happen. And the conclusion you'll say is we need to test and maintain our emergency tools and processes. Actually, what you don't. You need to do something slightly different. We find over and over again that special case that you're going to rely on, that thing that you're going to use that one time, just isn't there when you need it. And that's why when you take an infrastructure as code approach, you're able to build that into your operating models so that you're using those standard deployment and management and other tools as part of your daily operation. So don't try to rely on a weird load balancing thing that you'll just do that one time, because that one time will be when your hair's on fire and everyone's yelling at you. Instead, build your emergency management processes around what you do every day, around your deployment tools, around managing load balancers in the cloud so that you're spinning up whole new instances and then spinning down old ones. Don't apply the old technique, which was dependent on a broken model where it was instance management and hand configuration. give yourself lots of knobs and levers to use as part of those regular processes. By that, I mean, don't assume that you're not going to have operator or developer or business intervention into your processes. You hear a lot of people kind of going down this route, and they talk about sort of autoimmune diseases and other things. And what's interesting is that what you really want to do is make it easy for you to fiddle those bits. Again, an infrastructure as code approach is what you want. The last thing is focusing on reliability. That is MTTR, mean time to recover, versus mean time between failure, making sure that things never fail. It's almost always better to focus on MTTR, because MTTR lets you recover faster than trying to engineer and more cheaply than trying to engineer a system that never breaks, because I hope I've shown you that systems are going to fail. And of course, always automate all of the things. Test what you do and press the button. Thank you very much. I'm Jesse Robbins, and
thanks, sir. Give that to Becky. All right. Great, Jesse. Thank you very much.